everybody. It is Mike Levin on Friday, September 10th, 2021 at around 6:10 p.m. I'm heading out to pick up my kid and to bring her back for the weekend. The last at 11, Mike at 11 video that I shot was discussing the Vim text editor to potentially future Addie, if this kind of stuff is ever of interest to her, what her old man had to say to her. And I guess in the intervening time I had in looking at my YouTube statistics and such, thought to myself, what am I doing here talking about such things as a text editor to my future version of my daughter who might someday be watching these YouTube videos. That is, if YouTube is even a thing, if I am of interest, and if the videos are still even available. So, one of the things I'll be doing is downloading all my YouTube video source material from YouTube. I don't keep the original source material. It's just too much storage. You might say the cloud, and I'd be like, oh, especially if it's on the cloud, that's the most valuable type. It's backed up the best naturally from year to year, but it's on other people's computers, and you have to pay for it every year or else the hard drives disappear. Exactly what happens to that data, I am not sure, but when you stop paying for storage in the cloud, it goes away. And when you run a lot of storage, it starts to be as expensive as if you bought drives of that size and sort of a one-time deal, which of course have the vulnerability of they could crash. Then you'd wish you had a cloud backup. So I'll be addressing that issue. You should keep your own master files of stuff. The cloud is nice. The cloud is going to outlive you, probably. There, any service you're using, the residual files are probably going to have a longer life than you do. So there is that humbling fact. But there's something to be said about not having to pay and the data's still there, a sort of persistence of memory that is kind of part of you, part of your animal body, an extension of your DNA. And that is in the hardware that you buy and own personally. And since that kind of hardware is always going obsolete, just like the matter in your body is being replaced every 7 to 10 years in whole, except for a few parts of, I guess, your brain and your bones don't get recycled quite so fast. However, most of you is replaced every 7 to 10 years, so the question of what is you really comes into question. And also gives strong validation to the fact that you really must be expected to migrate any of your data or systems, your systems that are running off of data stores, archival data, scheduled tasks that should always be running. This stuff should be migrated from system to system over time to assure a certain timelessness, ruggedness, durability, long-lastingness. And this is thankfully an option when you go the Linux, Python, Vim, and Git route. There's a really lot of neat tricks you can do to get code running, both in the cloud and also in your own hardware. So I really need to be doing that, because one of the things you need in your life is a place to run some code that is not on the cloud, that poofs when you stop paying, or is on a free tier service. It's not really, reliable long term. You might forget about it. The commitment to keep it running might not be there. It might roll over and start start to actually be charged incrementally through a cloud change of policies, as opposed to stuff that's running on your own hardware. Now, on your own hardware, it could get unplugged, it could get broken. A number of things could stop stuff from running locally, especially if it's your local main work system, if it's your laptop that you work on. There's two kinds of local. One local is extremely interruptible, not reliable, likely to be asleep to conserve your battery and such. And so that would be your personal system, usually a laptop these days. However, even if it's a workstation and you have some sort of device that stays plugged into the wall because of maybe large monitors you're using for gaming, a specialized console for gaming, there's still going to be interruptions. The system is reboot or whatever. It's not a reliable place to run code long term. Something's always going to go wrong with that thing running that's supposed to be running. So the other kind of local hardware is local hardware that is not your main workstation. It's not where you normally are. And there's different ways to accomplish that. And so one of the ways I've been drawn to lately is the shell game. The shell game of Docker or Linux virtual containers, VCX I think it is. So Linux has basically rolled in these, the gist of Docker, what Docker promises and delivers, but into, the Linux standard now, basically. So Linux containers can be built under the specification provided by Linux organization itself. So that's a good platform to be on. You want to be creating your systems so that they can be instantiated and brought up under any Docker-like containerization system, so that you're not reliant on particular hardware, particular platforms. Well, hardware, true. Platforms, maybe not so much. There's still a bit of reliance there, and there's some interesting stories here about the binaries that are pre-compiled to run on certain hardware platforms, usually x86 because of the dominance of Intel style x86 from the Intel really old legacy of processors, from the 8088 to the 8086 to the 286 to the 386 to the Pentium class processors. And then there was a really classic design that was Pentium plus some multimedia processors using MMX. But Celeron, it might have been Celeron. There was a magical hardware platform that they hit, Celeron, I think it was, that it was the perfect 80-20 rule for consumer use and for fairly rigorous commercial use, so long as you weren't relying on 100% reliability. You'd have to reboot it every once in a while. So Intel later overbuilt, and then when they backed up and went to multi-core, they said, what is a good unit for one of these cores? What should a core be? And they went back to that old Celeron design. So when we're talking about stuff being compiled for the x86 platform, that's usually it. There's other types of Intel legacy compiles that are out there. Intel's own that was made for the Itanium platform, something that went a different direction than the Celeron multi-core direction. It was a different type of 64-bit, and I think the libraries for one type came from AMD and the other type came from Intel, and so that's why there's some confusion over the 64-bit binaries for the x86 platform. There's two, but one has sort of settled in as a winner. You don't see much like the Itanium hardware out there anymore, and it's generally referred to as x86 now, or 64-bit x86 binaries. And now there has to be 64-bit Mac binaries because of its hardware being different enough down at the machine instruction set level. So no matter what computer programming language you're using, no matter how abstract and high level it is, like Python, where it feels like you're working in some form of English, these things get compiled down. There's different words for it. Just-in-time compiled, P-code. There's a lot of ways it's handled, but it's turned into as low level of machine instruction code as can be permitted based on the dynamic features of the language you're relying on to otherwise do things. So things can be compiled down to a point with Python, not all the way. And that's where you get your .pyc files that you might see after you've run things with the CPython executable, a couple of times. It's going to put those pseudo binaries, those pseudo compiles in location so that things run faster the next time. And if you make changes to the text file, the script file, aka the source code, it will recompile and remake that .pyc file. Excuse me while I hydrate myself with some Coke. And so it is with high-level languages actually always getting things as close to the native platform's machine code as it possibly can to optimize runtimes and such. And sorry as I regain my train of thought there. So assembler, so why not just everything be done programmed in assembler? It's because the languages are full of nuance which matter. So you solve problems thinking the way you wish to think, using the language you wish to use. However, all these expressions, all these statements, all this code and programming that you make has to ultimately be compiled down to run on the particular hardware platform you're on. Even if it's a scripting language, even if it's an interpreted language like a Python, there are these pseudo compile steps now, almost always in the picture for runtime speed optimization, but they're only part way. So let's see, the point I was making there that brought me down that whole path. Oh, bringing together, yeah, I'm bringing together different of my free and open source little initiatives, and I'm doing it now in a way where I'm hoping to achieve a little bit of timelessness, maybe that has eluded me in the past. And I'm the kind of person who's been jumping from language to language, looking for secret weapons, figuring out how to do things before they were readily, easily to do. So I was essentially doing Ruby on Rails style slamming out apps on a generalized, joyous framework before a Ruby on Rails existed, and I got a lot of tricks out of that, including creating a Web 2.0 app called Hittail, and it was scaled to take advantage of exactly one island's worth of hardware. So the cloud was coming along, and there was, complex networks at the time. You could always build something out that could handle the work you needed to do, all locally in your co-location center. And that's basically what I did with the first go-around of Hittail. So I was handling the hardware directly, and there's a certain joy to that. I have fond recollections of launching Hittail, even while our IT guy was away on vacation or whatever. Me and a coworker at the time, Tanya Nam, we went to the co-location center, installed 3 machines, I think. One switch, router, installed a router. It didn't need a lot of configuration. You just needed a place for the internet drop to come to give you multiple ports, a switch. It was working as a switch, even though it was a full-fledged router. It didn't really need to be. We needed one easy local network, a LAN, local area network. So the switch gave us that. And then there were two more pieces of hardware, though. One that was the Microsoft IIS, Internet Information Server. You know, it was the web server of the day. And the other one was a database, a SQL Server database, set up with 4 drives to have a RAID 1 and 0 or 0 and 1. It was striped and mirrored. It had the benefits of both write speed and duplication mirroring. So data redundancy, so your data was safe, but it was also as fast as possible on the write because it could split a write over 2 write heads and write it in half the time. Really clever stuff. So I had a very certain joy in tweaking out the performance of this hardware. And it was, you know, whatever, $20,000 servers at the time. Now it's nothing that couldn't be done by a single Raspberry Pi with a big SD card. And there was a joy in the hardware at the time. And that came from the joy in the hardware from a prior generation, which was the Amiga hardware for me, which came from a sort of joy prior to that, which was never really that joyous, but the Coleco Adam limited bit of hacking I did with their data cassette tapes. Oh my God, where I started, my roots in computers. And the summer before that at overnight camp at Lake Wallenpaupack, up close to where I live now. Interestingly enough, things go full circle. After 15 years in New York City, I'm where I used to summer camp now. It was Camp Watonka at Lake Wallenpaupack. And it was a summer camp, science camp for boys when I was 12 years old. And I spent the summer there, and I was working on a TRS-80, or a Trash 80 as we like to call it at the time. There were like 2 Apple IIs there, and the cool kids rushed to get to the Apple IIs because you could do a little bit of graphics on that. And boy, if I struggled to be one of those cool kids, if I really pushed it, that was 1982. So I was doing computer stuff in 1982. And I was near where, you know, Unix was invented about 10 years prior to that in 1970 when I was born, you know, near Berkeley, New Jersey, and the Bell Labs facilities in New York and New Jersey. And so really, really close to where the East Coast part of the information age explosion happened, but it mostly missed me. I ended up with Commodore computers for a few years, but mostly as a student intern while I was working at college, and was the president of the local computer Amiga user group, the Philadelphia Amiga user group. And so I had a lot of interesting experiences, a lot of war stories here and there along the way. I flew on the airplane with Al Haig to go to a Commodore shareholder meeting to try and tell them everything they were doing wrong and what they had to do right to stay competitive in the new landscape. And this new landscape was basically the PC x86 landscape, which kicked Commodore's butt, even though they tried playing that same PC game with the PC-10 and the PC-30, and they had a couple of good holiday blockbuster, you know, seasons where they were $1 billion computer manufacturer, which was a big deal back then. However, it all fell out from under them because they just couldn't stay competitive with the rest of the world that was entering this rapid feedback cycle. This was the age of the Sound Blaster cards for audio. And, you know, graphics were not 64-bit yet. We're not 24-bit yet. You'd be lucky if you plugged in some sort of Targa card for photorealistic, 24-bit graphics. Not even 32-bit to get that transparency layer. So they were mostly thought of as photo buffers, to use high-end photo buffering software. Certainly not for playing Doom and then later Quake, and now these days with Halo and, you know, all these multi user multi-online things. I work for IGN. I work for the company that owns IGN. I should not be floundering for the name of Fortnite and its like now. So things just evolved so quickly, and the Amiga was a evolutionary branch of computing that more or less went extinct. There are some things keeping it alive here or there. The infamous, I'm not dead yet. The Amiga is the Black Knight in, Meaning of Life, hopping around going, I'm not dead yet. I still got one leg. And it had really good ideas, but really good ideas on their own don't float it. The BOS that inherited a lot of the Amigas and the Apple's spirit later on by some elite engineers that got together, and just like Steve Jobs made the next computer happen, and the ex-Atari engineers made the Amiga computer happen, even though it was subsequently bought by Commodore. Some other elite engineers made the B computer happen, and it never became popular, but it was very object-oriented. Its file system was a object-oriented database, blah, 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 blah. And the BOS continues on in some form these days. And so there's all, and Bell Labs themselves created B9, a replacement to the Unix operating system. So if you're chasing purity, some sort of purity, like next generation, like stuff farted out of the butts of angels, there's always something better that's being developed and coming along. But the question is it better enough to displace what's working good enough today? And usually the answer is no, such to the point that there's a certain calculus of efficiency. You flesh things out in the languages and the environments and the technologies and the tools that's comfortable enough to you today to do the fleshing out. And you get a fairly high resolution on first pass. This is the 80-20 rule. This is good enough is good enough. And then you enter into a rapid iterative cycle of constant improvement, continuous feedback and integration. There's a lot of words for it these days. Japanese Kaizen, total quality management. There's a bunch of stuff leading up to it, but the basic premise is that if good enough is good enough, then why not ship it and then listen carefully to make good enough even better, and then enter a righteous, rapid feedback cycle of improvement. In the case of Intel, you can even formalize that into the ambitious cycles of reinventing large swaths of your, infrastructure and gutting parts and replacing it, and the slightly more lazy TOC. So that the previous was the tick cycle, and the second is the TOC cycle, which is building upon the innovation you just did to get incremental improvement. So you're always squeezing that lemon for the last bit of lemon juice, or orange for orange juice, whatever your poison. And the irony being, Andy Grove, who was leading Intel for a while, who coined the phrase "only the paranoid survive," he retired, but left Intel in some pretty good hands. People who, pulled the Intel multi-core processors out of the fire, the Israelis really, of the Fab 8 facility, to, backtrack on the Itanium 64-bit debacle and put out more consumer-friendly multi-core Celeron-like, processors that can be scaled up, because now, that's a lot like a node in a neural network, so you can eventually get it out to 100 instances of those cores. And so there's a cool upgrade path. So Intel jumped on that bandwagon, but in the race to miniaturize the actual circuits themselves, well, they were double whammied. They were whammied on the one side by the race to reduce the circuits themselves, And while they were up at that, barely at that 7 nanometer scale, getting it down from a recent record of 15, which was down from a recent record of some 24 or 30, all of these which are miraculous, mind you, all of these which have to take into account quantum tunneling effects. So they got manufacturing pretty small, but Hong Kong goes and gets it down to 5 nanometers. And when you combine that very tiny manufacturing with the other whammy of the Intel double whammy that hit them, on the other side is the ARM architecture, the ARM machine instruction set architecture and design specifications from the ARM, the British technology holding company that first was originally the Acorn computer. It was sort of in the heritage of the BBC Micro, right? So the British want to educate their whole population, so they use the power of television, and they had a computer designed to go along with a BBC series that was being broadcast. So that computer was the BBC Micro, and that started a tradition of such computers, and one of them being the Acorn. So Acorn is one of the companies that was vying for the sweet contract of being the BBC Micro, a next generation one. I don't know if they ever got it or not, but in the effort of doing that, they slapped together computers just like the way Radio Shack did with their Cocos and Commodore did with their VIC-20 and later the Commodore 64. But when they did it, they decided they wanted better graphics capabilities than the way Commodore was doing it, which was going with a multi-chip design. It was both expensive for more chips, and it made you dependent on the provider of those chips. And Commodore bought MOS Technologies at the time, so if you wanted the cheap version of the Motorola chips, 6800 chips, the cheap version of the 6800, this is not even the 68000 that went into the early Macs and Amigas and Atari 520 STs and stuff. But if you wanted the $25 version of that chip instead of the $250 version, then you got the cheaper knockoff from MOS Technologies, from Conshohocken, from Norristown, Pennsylvania. Again, a factory right near where I grew up. I grew up in Lafayette Hill, and Norristown was right down the street. So both the chip factory that Commodore bought and the Commodore headquarters itself was up the street from me, a 40-minute drive and commute. So I started out working there as a college student, as an intern from Drexel University. So what a dream is that? You get to be the nerd, the computer nerd, beamed up by the mothership, all of which is in your backyard, miraculously. So even then, all the talk was about the West Coast, but I'm here going, MOS Technologies, Commodore, even New York City, being there, and early jobs, being in the Virginia area because of Washington, D.C., and I'm like, yeah, I don't really need the West Coast. There's a whole lot here, and it's my roots. But little did I know that roots were overrated. So a big part of the human condition is to deal with the hurt of getting ripped up from your roots sooner or later. That very British concept of the home you grew up in, that your parents bought, that 80s vision of the ticky-tacky house. Well, it's going to be left to all the kids. One of the kids is someone going to carry the torch for the parents and to step into a version of their life and to become little American versions of like British estates. This is all very new. This is suburban sprawl following World War II. This is the New Deal leading into the GI Bill, and what to do with all this excess economic capacity that the United States had. So they put it into every man's home is his castle. So we're dealing with